Somewhere, far beyond the reach of our most powerful telescopes, the light from entire galaxies is fading into darkness. It's not because something has swallowed them, nor because they have vanished. The truth is far more unsettling. They are simply drifting away, carried by the slow expansion of space itself, until their light will never reach us again. In that moment, they will be gone, not destroyed, but lost forever to the silent void. This isn't just happening somewhere far away. It's the quiet beginning of the end for everything we know. The universe is old, about 13.8 billion years, give or take. That might sound like an impossibly long time, but in cosmic terms, we may still be living in its vibrant youth. Stars are still being born, galaxies still collide, and the night sky still holds its dazzling display. Yet, when we look deeper into the future, the story turns somber. The cosmos is not static. It changes, it ages, and like all living things, it will eventually die. The slow death of the universe is already underway, and once it starts, there is no way back. It's a process so gradual that, for billions of years, no single observer will ever notice it happening. Yet, from the perspective of eternity, it is relentless. Astronomers call it the heat death, but the name is misleading. It's not a fiery end. Instead, it's the opposite. It is a universe growing cold, dim, and empty, one quiet step at a time. Imagine a grand symphony fading not into a final crashing note, but into silence so deep that you begin to forget there was ever music at all. The first act of this cosmic fading has already begun. The expansion of the universe is accelerating, something first discovered in the late 1990s when scientists measured the light from distant exploding stars called supernovae. To their surprise, these cosmic explosions were dimmer than expected, meaning they were farther away than they should have been. Something was pushing the universe apart faster and faster. We now call that mysterious force dark energy. And dark energy is the architect of the universe's eventual solitude. If dark energy keeps working as it does today, then billions of years from now, every galaxy outside our local group will disappear beyond our cosmic horizon. The night sky will become emptier, not because the stars have died, but because their light will no longer be able to reach us. Imagine looking up at the sky and seeing only the faint haze of our own Milky Way, with nothing else beyond. Future astronomers, if any exist, will never know that the rest of the universe was ever there. They will be isolated in an island of stars, unaware of the vast cosmic ocean that once surrounded them. Even before that lonely future arrives, the stars themselves will begin to change. Right now, new stars are forming from the clouds of gas and dust left over from earlier generations. But those raw materials are finite. As galaxies age, their star-forming fuel runs out. The brilliant blue giants we see today will die in spectacular supernova explosions, while smaller, steadier stars will quietly burn for billions of years before fading into white dwarfs. Eventually, no new stars will be born. The galaxies will turn dark, lit only by the dim glow of ancient, cooling embers. This phase of the universe's life is sometimes called the degenerate era, a time when almost all matter is locked into slowly cooling remnants. White dwarfs, neutron stars, and black holes. The night sky will no longer shimmer with youthful brilliance. Instead, it will be populated by faint, lonely points of light, spread farther and farther apart as space stretches into the infinite. The beauty of the cosmos will not end with an explosion, but with a whisper. Black holes will remain silent guardians of the last pockets of mass in the universe. They will consume what they can, growing slowly heavier, until even they begin to fade. According to Stephen Hawking's predictions, black holes will eventually evaporate through a process called Hawking radiation, shrinking over unimaginable spans of time until they vanish completely. When the last black hole dies, the universe will be left with only the faintest traces of energy. Ghostly photons stretched so thin by the expansion of space that they will never again collide with anything. This is the heat death, a state of maximum entropy, where all the energy in the universe is evenly spread out and no work can be done. It's a cosmic stillness where nothing changes, because there is nothing left to change. No stars, no galaxies, no light. Only darkness and an endless silence. And here's the most haunting part. This is not science fiction. It is the inevitable consequence of the universe we live in, given enough time. But how do we know this is truly the fate of everything? What if something, some unknown force or event, changes the story before we reach that point? The universe has surprised us before. The question is, will it surprise us again?
For all its inevitability, the heat death isn't the only ending scientists have imagined for the cosmos. The universe has a way of keeping its secrets, and our understanding of its fate is built on what we can observe right now. If any one of those cosmic parameters changes, even slightly, the future could be radically different. And that's where things become interesting. While the slow, cold fade may be the leading theory, other scenarios are lurking in the shadows of possibility, each one stranger than the last. One alternative is called the Big Crunch, a cosmic rewind of everything we've ever known. In this version of the story, the universe's expansion eventually slows, stops, and reverses. Galaxies begin to drift back toward each other. Stars grow brighter as their light is compressed, and space itself contracts. Over billions of years, the universe shrinks into a smaller and smaller volume, until all matter and energy collapse into a single, unimaginably dense point. This moment, if it ever comes, would mirror the Big Bang in reverse. But it would not be a peaceful end. The final moments of a big crunch would be catastrophic, and perhaps, just perhaps, the prelude to a new beginning. That idea that a universe could collapse and then be reborn leads to another theory, the cosmic bounce. In this model, the Big Bang wasn't the absolute beginning of time, but simply the most recent chapter in an eternal cycle. Our current universe may have emerged from the death throes of a previous one, which itself was born from another before it, stretching back into infinity. If this is true, the slow death we imagine might only be a pause before the next great expansion. But even if that sounds comforting, we have no proof and no guarantee that our next universe would look anything like this one. Then there's the Big Rip, arguably the most unsettling possibility of all. This ending depends on the nature of dark energy. If dark energy isn't constant but instead grows stronger over time, it could eventually overwhelm every force in the universe. Galaxies would be torn apart first, then solar systems, then planets, and finally atoms themselves. Even the most fundamental building blocks of matter would be ripped into oblivion by the ever-accelerating expansion of space. Compared to this, the slow death of heat death almost feels merciful. So why, if these endings are possible, do scientists still lean toward the slow fade into darkness? The answer lies in the evidence we have. Every measurement we've made so far of galaxies drifting apart, of the afterglow of the Big Bang, of the way the universe's large-scale structure behaves, points toward a constant rate of acceleration. And if that acceleration stays constant, the Big Rip is off the table. The Big Crunch is even less likely, because it would require gravity to eventually overpower dark energy, something we see no sign of happening. All roads, it seems, still lead to the long, cold twilight. In this view, time stretches on almost without end. The scale is so vast it defies imagination. Stars living and dying over trillions of years, black holes evaporating over time spans that make the current age of the universe look like a blink. For any conscious beings who might exist in that far future, the night sky will be nothing like the one we know. There will be no galaxies beyond their own, no new stars being born, no way to guess that the cosmos was once a place of light and life. They will live in an island universe without knowing the ocean ever existed. And yet, there's a strange beauty in this inevitability. The slow death is not violent. It's not chaos or destruction. It's the universe gradually falling into a deep sleep, its restless energy finally spent, its fires extinguished one by one. In a way, it's the most fitting end for a cosmos that has carried on for so long, an ending that mirrors the quiet stillness of space itself. But just because the end is peaceful doesn't make it any less haunting. It leaves us with an odd question. If the universe is destined to grow dark and empty, what does that mean for the meaning of everything that happens in between? Are we simply a flicker in the night, a brief flare of complexity before entropy takes over? Or is the very fact that we can ask these questions proof that the universe's story, however brief, is still worth telling? These are the thoughts that make the slow death feel less like an ending and more like a mystery still waiting to be solved. And there is one final twist. Even in the farthest reaches of time, long after the stars have gone out, the universe may still not be entirely dead. There will still be motion, still be faint energy scattered through the emptiness. And in physics, as long as there is energy, there is the possibility, however small, that something unexpected might happen. Could that something be enough to start the cosmic cycle all over again? Or will the universe's final secret be that there are no more surprises left?
The idea that the universe could one day die is not something ancient skywatchers could have imagined. To them, the heavens were eternal. The stars appeared each night in their familiar patterns. The planets followed their predictable paths, and the great dome above seemed unchanging. It wasn't until the last century that humans began to realize the cosmos was not a fixed stage, but a living, changing entity with its own life cycle. And that realization began, as so many great discoveries do, with a single, unexpected observation. In the 1920s, astronomer Edwin Hubble peered through the 100-inch Hooker telescope and noticed something remarkable. The galaxies he studied weren't just moving through space. They were all moving away from us, and the farther away they were, the faster they seemed to recede. This wasn't because Earth was special or because everything was fleeing us personally. It was because space itself was expanding, carrying galaxies along like leaves on the surface of an inflating balloon. That single discovery changed everything. If the universe was expanding, then at some point in the past, it must have been much smaller, denser, and hotter. The idea of a cosmic beginning, the Big Bang, was born. For decades, scientists assumed that gravity, the force pulling all matter together, would eventually slow this expansion. The question was how much it would slow. Would gravity win in the long run, pulling everything back together in a big crunch? Or would the expansion continue forever, coasting to a gentle halt? No one imagined that the opposite could be true, that the expansion might not just continue but accelerate. That idea seemed impossible until the late 1990s, when two independent teams studying distant supernovae found the same unsettling result. Those exploding stars were fainter than expected, meaning they were farther away than they should have been if the universe's expansion was steady. Something was pushing space apart faster and faster. That something was given a name: dark energy. To this day, we don't know exactly what dark energy is. It might be a property of space itself, or some unknown form of energy permeating the cosmos. But whatever it is, it now makes up roughly 70% of the universe, and it is the reason the slow death is our most likely fate. From that moment, the path forward became clearer. If dark energy remains constant, the universe will keep expanding forever. Galaxies will slip beyond our horizon, star formation will fade, and eventually all matter will be reduced to cold remnants drifting in the dark. And the more we looked, the more the evidence supported this scenario. The cosmic microwave background, the faint afterglow of the Big Bang, matches perfectly with a universe that will never stop expanding. Observations of galaxy clusters and large-scale cosmic structures fit the same picture. It's as if the universe is quietly telling us its own ending, if we know how to listen. But listening is not easy, and the scale of the story is difficult to grasp. Consider this: right now, there are perhaps 2 trillion galaxies in the observable universe. In 100 billion years, our descendants, if they are still here, will only be able to see the galaxies of our local group. Beyond that, the rest will be invisible forever. Future astronomers might never suspect they were missing the grand majority of the cosmos. They will live in a bubble of ignorance, not because they lack curiosity, but because the evidence will have literally vanished. And yet, humans of today live in a unique window of time. We exist in the rare era when the universe is old enough to have formed stars, planets, and life, but still young enough that we can see the vast expanse beyond our local neighborhood. We are cosmic witnesses to both the universe's flourishing and its inevitable decline. It's a bittersweet privilege, one that no civilization billions of years from now will share. This understanding doesn't have to feel hopeless. If anything, it deepens the meaning of our place in the cosmos. The fact that everything we know will one day fade makes our brief existence all the more precious. It's as if the universe is a grand story written in starlight, and we just happen to be reading one of its most vibrant chapters before the final pages turn. That realization can stir something deep in us, a quiet urgency to observe, to learn, and to leave a trace for those who come after. But there's a haunting question. What could our descendants actually do in the face of the slow death? Could a civilization so advanced it spans entire galaxies find a way to outlast entropy? The laws of thermodynamics suggest not. No matter how much energy you have, you can't create order from nothing forever. But perhaps there are ways to delay the inevitable, to shelter in small corners of the cosmos where warmth and light linger just a bit longer. If the universe is heading for eternal night, maybe survival will depend on carrying a spark of light into the darkness. And that is where the story begins to shift from pure science to speculation, an exploration of the strange and imaginative possibilities for life at the end of time.
If the slow death of the universe is unavoidable, then survival becomes less about preventing the end and more about postponing it. This is where imagination meets physics, and where science fiction begins to brush against the edges of science fact. Even in a universe running out of energy, the rules of nature might still allow clever beings to find pockets of life, small, fading embers where heat and light persist long after the rest of the cosmos has gone cold. One idea is to migrate toward younger stars. In the distant future, most massive stars will have burned out, leaving only smaller, cooler red dwarfs. These stars can burn for trillions of years, far longer than the sun's 10 billion-year lifespan. A civilization capable of interstellar travel might choose to hop from one long-lived star system to the next, stretching their survival across unimaginable spans of time. But even red dwarfs will eventually die, leaving only the faint heat of white dwarfs behind, and the journey would become harder with each step into the dark. Another possibility lies in artificial habitats. Imagine vast space stations built around the last sources of energy in the universe. Perhaps the dim glow of cooling neutron stars or the heat leaking from the surfaces of ancient white dwarfs. In these last oases of warmth, life could continue, sheltered in engineered worlds insulated from the cold. The challenge, however, is that no matter how well-built these refuges are, their energy supply will still dwindle over time. The question is not just where to survive, but how to sustain survival when the universe offers nothing new. Some scientists have even speculated about harnessing black holes. While they may seem like cosmic destroyers, black holes could be valuable in a dying universe because of the energy they emit through Hawking radiation. In theory, an advanced civilization might orbit near a small, slow-evaporating black hole, capturing the trickle of heat and light it releases. The smaller the black hole, the more energy it radiates, though smaller ones evaporate faster. It would be a delicate balance, like living beside a fire that grows weaker each year, forcing you to move closer until there's nothing left. But perhaps the most audacious idea is not to survive in this universe, but to leave it entirely. Some theories in physics suggest that our cosmos might be just one bubble in an infinite multiverse. If this is true, there might be ways, though purely hypothetical, to tunnel into a younger, more energetic universe. The journey would be beyond anything we can imagine today, requiring control over energy and space on a scale that makes even galaxy building look small. But if the alternative is fading into the dark, perhaps civilizations will try anything to find a new home. Of course, all these ideas depend on something we can't predict: whether any civilization will last long enough to even attempt them. Humanity itself is young, barely a blink in cosmic time. We have not yet solved the challenges of surviving on a single planet, let alone migrating through the stars for trillions of years. The universe's slow death may give us more time than we need, or far less, if we are undone by our own mistakes before entropy ever reaches us. And yet, there is a strange hope in imagining the far future. Even if the odds are against us, even if the ultimate outcome is silence, the idea that life could stretch its existence to the edge of time is a testament to resilience. It reframes the slow death not as a sudden collapse, but as the longest sunset in history, one in which the last observers could watch the final stars flicker out and still whisper to themselves that they had witnessed the end. But perhaps the most haunting thought is this: maybe we are not the first to face this question. If the universe has gone through cycles before, if other civilizations in other cosmic eras have risen and fallen, then the slow death may have been seen many times before. And somewhere, scattered across the deep past, There might be traces of those who tried to fight the darkness and failed, or perhaps succeeded, leaving for another universe entirely, never to return. For now, we can only wonder. The tools to answer these questions are far beyond us, and the answers themselves may only come when the last stars are burning low. Until then, we live in the bright middle of the universe's story, with more light than darkness, more time than memory. And perhaps that is enough for now. In the end, the slow death of the universe is not just a story about physics. It's a mirror we hold up to ourselves. Every star that fades, every galaxy that drifts away, reminds us that nothing in the cosmos is permanent, not even the cosmos itself. And yet, here we are, alive for this brief moment, capable of seeing the pattern and understanding the ending. The universe will not notice our presence, but we can notice it. Right now, our night skies are still rich with light. The Milky Way arches overhead in a pale, shimmering band. Distant galaxies like Andromeda glow faintly through the haze of our atmosphere. Star-forming regions pulse with newborn brilliance. It is a privilege that no beings in the far future will share. We are witnesses to a chapter of cosmic history that will one day be erased, not by force, but by time itself. And perhaps that's why this knowledge matters. Knowing the ending doesn't make the middle less important. In fact, it makes it more urgent. The beauty of a sunset comes not despite the fact that it will end, but because of it. The universe is not just a place. It is an unfolding event, and we are part of its fleeting glow. The slow death may be inevitable, but between the first light of the Big Bang and the last whisper of entropy lies every act of creation, every spark of life, and every moment of awareness. There's also a certain peace in accepting what we cannot change. The heat death is not violent. It will not come crashing down in fire and chaos. Instead, it is a gradual softening, a long unwinding of energy into perfect stillness. The last observers, if there are any, will not see an ending so much as a vanishing, a slow drift into a darkness so complete that memory itself might fade. And yet, that darkness is simply the final note of a song that has played for billions upon billions of years. The real question is not how the universe will end, but how we will live knowing it will. Will we turn away from the vastness, pretending it has nothing to do with us? Or will we lean into it, letting its scale and its fragility shape the way we see our lives, our choices, and each other? If the cosmos is temporary, then so is everything within it, and that means every act of kindness, every discovery, every connection matters even more. When future astronomers, if any remain, look up at the sky and see only the stars of their own galaxy, they will have no way of knowing the universe was ever bigger. We, however, know the truth. We have measured the stretching of space, traced the afterglow of the Big Bang, and mapped the great web of galaxies. We have seen the universe in its fullness, and we can tell its story. That story will not save the cosmos from its fate, but it might save us from forgetting who we are and where we came from. So perhaps the point is not to escape the slow death, but to cherish the time we have before it arrives. To stand beneath the stars, not in fear of their fading, but in gratitude for their light. To pass on our knowledge to future generations, even if they will see a smaller, darker sky. To live as though our brief flicker in the cosmic dark is worth something, simply because it is ours. And maybe, just maybe, there is a final twist we cannot yet see. The universe has surprised us before, showing us that space can expand, that invisible forces can shape its destiny. If there is another surprise waiting, it will likely be hidden deep in the laws of physics we have yet to uncover. Until then, we carry both truths in our minds, that the slow death is inevitable, and that the story is not yet finished. For now, we are here. The stars are still shining. The galaxies are still calling to us across the light years. And if you listen closely, past the silence of space, past the ticking of cosmic time, you can almost hear it. The faint hum of the universe, still alive, still unfolding, still ours to explore. So, while the night is still bright, let's keep looking up together. If you've enjoyed this quiet journey through the cosmos, consider subscribing and joining us again for the next chapter. Until then, sleep well beneath the stars.